All right, guys, let's move into number one. Number one, we're working with order of operations on integers. So remember your order of operations, parentheses, exponents, multiplication, division, addition, subtraction. It gives you the order of which to do things. Right away here, this is one of the most common mistakes that I see in Algebra 2. This is really read the opposite of 4 squared, or you could read that as -1 times 4 squared. What you have to recognize is that you are actually performing the operation of the exponent before you're applying that negative. So what we want to look at here, in fact, I could even think of this as -1 times 4 squared, or I could think of it as -1 times 4 times 4. But the square is being applied to the 4, not to the negative. Versus if I look at the second part of, or the backhand part of the problem, -4 squared, now this one here, the square is being applied to the negative. So this is -4 times -4, which I think we all know. What is -4 times -4? So the opposite of 4 squared is -16. But -4 times -4, a negative times a negative is a positive. So this one's going to be a positive 16. And then the first one is going to be a -16. That can be confusing. In fact, if you, I know this is a non-calculator example, but if you typed this into your calculator incorrectly, your calculator would say, oh, well, it depends how you typed it in. If you typed it in like that, your calculator knows its order of operations. So it would say, oh, it's -16. Versus if you typed it in like this, where you put the parentheses around the -4, the calculator would spit back a positive 16. Because the calculator is really following that order of operations in how you type it in. Okay, so we have -16 minus 10 plus 16. Then we just go straight through, left to right. -16 minus 10 is -26. Plus 16 gives us -10. Don't know why this is glitchy. All right, let's move on to number 2. Number 2, what do you think we should do first? The exponent, I heard it. So we've got 2 squared. That's that exponent. 2 squared is 4. So I have 4 times -3 over there. I have 6 times -5 over here, and then minus that. What comes after exponent? Multiply. So what's 6 times -5? -30. What's -3 times 4? -12. But then I have this minus here. As I'm moving left to right, what happens with a minus a negative? Good, it becomes a positive. And I have -30 plus 12. -30 plus 12, what does that come out to be? -18. All right. Moving on to number 3. Number 3, more working with integers. My surface is super glitchy. I don't know what's happening there. There we go. All right, number 3. Number 3, what is first in your order of operations? Parentheses. So what is 1 minus 4? -3, good. So I have -3 squared. I have the minus on the outside. And then I have the -5 minus -4. Go ahead, finish this one on your own. See if you can catch that minus on the outside. I'm going to do a quick walk around, see how you're doing with it, see if I can help you at all. All right, guys, I'm seeing good things. -3 squared does create a +9, but then we have to apply that negative. Be careful not to do this minus negative and make that a positive first. If you do that, you're not using the order of operations because you have to do the exponent before you multiply. In fact, if ever this was given to you on like a quiz or a test or in a homework, if you want to, anytime you see a negative outside, you could technically call it -1. That's always valid, and that sometimes that helps you think through it. -3 squared is 9. 9 times -1 is -9. And then we have -5 minus the negative creates a positive +4. And then we have -14 plus 4. What is wrong with my computer? Gives you -10. All right, number 4. Number 4, the person with the longest hair in the group. You turn to your partner and share what you would do first. What would you do first?
So, and then put the negative sign next to it.
When I write it down, I feel like
Yeah, so we negative 10 minus 4, right? Yeah. Yes, awesome. So you're longest here, so you would just share that. Jacob, right? Jacob. And
All right, I'm hearing good things. So we've got -2 squared is +4. -10 minus 4 gives me -14. Nice. And I don't know what's going on with that. There it is. Okay, on to the next page. Now that we've warmed up working with order of operations with integers, let's take a look at working with order of operations with rational numbers, aka fractions. Let's quickly review what we have to know about working with fractions, and then we'll work with our order of operations. When multiplying fractions, you multiply across. So notice property 1, this becomes A times C over B times D. When dividing two fractions, to simplify, you multiply by the reciprocal of the second fraction. So C over D changes to D over C, and that divide sign changes to a multiply. When adding two fractions, you need a common denominator. Then you can combine the numerators and keep that denominator the same. If the denominators are different, you need to do some maneuvering to make them the same. So you can see what the problem would be here. We multiply this by B over B and this one by D over D. And that's where you get that AD plus BC over BD. Number 5, this is really important in simplifying fractions. Any number divided by itself is 1. So A times C divided by B times C just simplifies to A over B. And you can see that in a real life example right to the, or a real number example off to the right. 5 divided by 5 is 1, so the answer is 2/3. Last but not least, if you have an equal sign between two fractions, if you have really equivalent fractions, you can use what's called the cross product property, where you have A times D equals B times C, but you can only do that if there's an equal sign. If that's not there, don't do any weird multiplying. Last thing to make note of, sometimes we forget there are invisible parentheses. Man, this is really glitchy. There we go. There are invisible parentheses around values in the numerator and denominator. How does that make sense? If you look at ones like number 6, some people think, oh, I need to do this division first because order of operations, you would think divide before you add. But these guys have invisible parentheses around them. They're grouped. So you need to combine what's in the numerator first, combine what's in the denominator first, and then divide. All right, let's start working now with number 3. Again, this is no calculator, so let's make sure we can do what we need to without that calculator. First thing we need to do is parentheses. So as I see these parentheses, I'm subtracting two fractions, but I would need a common what? Denominator, good. So what am I going to multiply 1/4 by? Let me ask this. What's the least common denominator between 9 and 4? 36. So we're going to have to multiply this by 9 and 9. And we're going to have to multiply this fraction by 4/4. So that gives me -8/36 minus 9/36. And I need to simplify my parentheses, so I might as well keep going right here. Now the denominators are the same, so we keep the denominator. This is all going to be over 36. And combine the numerators. What's -8 minus 9? -8 plus 9 is 1, which is good. Tamikio? Yeah. As long as the denominators are the same. So yes, if it was like a 10 and a 36 and an 8 and a 36, you could reduce all of those by 2, and then you would have a denominator of 18. That would be great to do. Good question. Jay?
So it'd be 17, -17.
Perfect, -17. So we have -17/36 minus, now let's go ahead and do these parentheses. You could, again, treat this like a -1, or you could just see it as a minus. In either rate, what is a minus a negative, or a negative times a negative? Positive, good. My husband and I, when we were first married, we'd always have that like running joke where if he did something wrong, you know, like 2 wrongs don't make a right. If he did something wrong and then I did something wrong, he would be like, 2 wrongs don't make a right. And I'd be like, I'm a math person. 2 negatives make a positive. So, I mean, obviously it's not good to pay back somebody, like pay evil for evil, but I don't know, we would have that running joke together. So, but then he started using it and I was like, okay, no, I won't repay back your negative for a negative. Okay, so we have -5/18 plus 1/2. What would I have to multiply this fraction by to get a common denominator? 9/9, good. And I still have that minus on the outside. And that gives me -5/18 plus 9/18. Now the denominator is the same. It's all over 18. But I do need to combine those numerators. What is -5 plus 9? 4, good. So I have 4/18. And now I need to simplify this all the way. I have -17/36 minus 4/18. What's the least common denominator between 36 and 18? 36, good. So I'm going to multiply this fraction by what? 2/2. And then I have -17/36 minus 8/36. The denominators are the same, so I can put them over 36. And then what is -17 minus 8? -25. Good. All right. Have I talked to you guys about your college algebra textbook yet? I did. I told you how the beginning unit is the prerequisite unit. Okay, so these fractions, hopefully you've worked with fractions in Algebra 1, but again, we're reviewing them so that you feel confident about them before we start working with like rational functions. So with that said, I just want to get a quick like data point about how comfortable you felt with that problem. So what I'm going to ask for you to do, kind of like heads up, 7 up. If you could put your heads down on your desk and close your eyes, heads down, close your eyes. Reason why I just like you guys to give me a assessment of how you're doing without anybody else looking. So I'm going to ask you to just hold up a thumb. Up is I remember fractions, that was easy. Side is like I need a little bit more practice. Down is like I have no idea what you just did. So just give me a thumb. Up, side, or down. Up, side, or down. All right, thumbs down, heads up. Thank you. That's helpful to me. All right, on to number 4. Number 4, again, I'm dividing 2 rational numbers, fractional numbers. Wait a minute, how could 4 be written as a fraction? 4 over 1, awesome. So right now I have 4 over 1 divided by 4 over 5. Review from Algebra 1, this is the same thing as taking 4 over 1 and writing it that we're dividing by 4 over 5. Hopefully you guys remember that these bars are the same thing as a division symbol. Now that I maybe see it written in that way, how do I simplify? Yes, nice. We need to flip it. So 4/5 is going to become 5/4. And that divide sign is going to be changed to a multiply symbol. And always keep the position of the first fraction. So we have 4 over 1 times 5 over 4. Now you can multiply straight across. I could do 4 times 5 is 20. 1 times 4 is 4. 20 divided by 4 is 5. Or because it's multiplication, you can reduce common factors. 4 goes into itself 1 time, into itself 1 time. And so our answer is 5 over 1. Or you could just say 5. But if you called that 20 divided by 4 and then said 5, that's fine also. All right, number 5. Number 5, I have 4 divided by 4/5. Woo, where'd it go? There we go. Man, this is super glitchy today. Okay, I have 4 divided by 4/5. That's the same problem we just did. So again, I'm going to call that 4 over 1. And this is being divided by 4/5. And then I have minus 4/5 divided by 4. What should we do first? Division. I just highlighted those in green up here. Division or subtraction? I'm going to highlight that in orange. What comes first in the order of operations? Division or subtraction? Division. So we need to divide. I need to divide those two. I need to divide 4 over 1 divided by 4/5 first. And I need to divide these two. I need to divide 4/5. Take that and divide it by 4 over 1. I need to do those operations first before I subtract. So 4 over 1 divided by 4/5, we just did this one. We know to multiply by the reciprocal, change that to a 5 over 4. So I have 4 over 1 times 5/4. Same thing, 4 goes into itself 1 time. So this simplifies to 5. So I can go ahead, bring that down, say that simplifies to 5. Now, this piece over here, we just practice this. You try it on your own. See if you can simplify 4/5 divided by 4 over 1. All right, for road excellence, raise your hand if you can tell me. What did this turn out to be? 4/5 times 1/4. What did it come out to be? Not confident? Are we tired? Do we have fat puppy syndrome after lunch? Davis. Yes, nice. That does simplify to be 1/5. Because 4 goes into itself 1 time, into itself 1 time. And we have, this is what it simplifies to. And now we have 5 minus 1/5. Okay, how do I take 5 and subtract 1/5 from it? Any ideas? Make it as a fraction. So if I call this 5/1, awesome. What would I multiply this by? 5/5, good. So that becomes 25/5 minus 1/5. And that becomes 24/5. Or did anybody else look at that in a different way? Josh,
4 and 5.
awesome. How'd you think of it in that way?
The
You just took 1/5 from 5? Great. If you take 1/5 from 5, that becomes 4 4/5. Do you guys remember how to change an improper fraction to a mixed number? Just as a quick reminder, you'll ask how many times does 5 go into the numerator evenly? So 5 goes into 24 4 times evenly. But then how many remainders do you have? 4. So it's 4 4/5. So just a quick reminder for working with improper fractions and mixed numbers. Nice. Last one. Numero 6. Number 6. Okay. I reviewed that you have to simplify the top and the bottom before you divide. They have invisible parentheses around them. What is the least common denominator between 5 and 2? 10. Good. So we'll multiply this fraction by 5/5. This one by 2/2. And that's going to become 4/10 plus 5/10, which creates 9/10. Nice. And then what's the least common denominator between 10 and 15? Does anyone know? Let me take you back to algebra. Oh, it is 30. Good. But let's say we didn't know that. Let me take you back to algebra 1. You can factor down 10 to 5 and 2. You can factor down 15 to 5 and 3. What number do they both share? 5. So we don't need a 5. What is the 15 missing from the 10? What's a 2? So I would multiply by 2/2. What is the 10 missing from the 15? From the 15? A 3. So I would multiply by 3/3. Or I could say the least common denominator is 30. But that's kind of a nice way to just kind of review that. So we have 3/30 plus not 2. What should that be? 6. 3 times 2. Thank you. 6/30, which becomes 9/30. Awesome. And we just did quite a few of these, taking a fraction or a whole number and dividing it by a fraction. I'd like you to turn to your partner and the person with the shortest hair in the group. You share how you would finish this. Finish.
All right.
All right, for Road Excellence Junior Partner, someone raise their hand and tell me, what did you get as an answer? How did you do this? Let's see, Joe F.
Well, I divided them. So
Nice,
I did the change opposite.
nice,
I got 3.
nice. So you did 9/10 times 30/9?
Yeah.
How'd you get 3? It's right. How'd you get 3?
Oh, well, 9 goes into itself sometimes.
Nice,
And then 30 times 30.
good, good, nice. So the answer's 3 because you can divide by 10 and you can divide by 10, right? 10 divided by 10 is 1. You could do that here also, like 10 goes into itself one time and into 33 times. Either way is great. You just do have to simplify to that 3. Nice. Good job, Joe and Ava. All right, guys, I just emailed you a link. So the homework is to finish the worksheet for tonight, but I just emailed you a link in your on-campus messages. I did it like 5 seconds ago. Before we leave here, I'm going to have everyone sign up for quizzes.com. You don't have an assignment through quizzes tonight, but you will on the block day, Wednesday. So just so that we're all prepared for that, I just need you to sign up for the class. So what you'll do is you'll click on that link that you were just sent on campus. I'll show kind of who's entering the class to make sure your name is up before we leave. The quizzes will ask you to sign up through Google or Microsoft. It doesn't matter which account you choose, but if you want to be sent email reminders, or if you didn't catch in class that you have a quizzes due, it will email whichever email you sign up with. So maybe choose the email that you check most often. Quizzes will also ask you to put a parent or guardian email address. You do not have to type in your parent's email. You could type in your email. Truth is, I will never email your parent through this website. On campus will show your score. I don't use this one for scoring. I just use it for recording the data. But after you have that, you'll press accept invite, and then you're in the class.
You say email?
I messaged on campus. Sorry, I messaged on campus. And then I'll go ahead and show you guys what, if you're in, they organize you guys by first name, which is weird. What they do. Do make sure that you list your full name though, so when you do have an assignment through this avenue, I can give you full credit for your assignment. If you put a nickname, I might not know who it is, and then I can't give you credit for it. So let's see who we got. Alex is in, it's in. I've got 9, and I need 1, 2, 3, 4, 5, 6, 7, 8. I need 23. Davis. Let's see, not yet, but let me refresh it. As soon as you say accept invite, it should put you in. I just might need to relog it. Not yet. Did you click accept invite?
Oh, here we go. Yeah, it's not that.
Sweet. No, not very, very, very far. Let's see. Okay, I've got 16 so far. Doing good, we're doing good, we're doing good. Davis, I still don't have you. Did you say accept invite? Wait, I'm in the wrong one. Sorry. There we go. Yeah, there you are. So now I have 17. It's all I have you, Claire. I don't have you yet. Do you see the accept invite, Claire? Okay, awesome. Matthew, do you see the accept invite? It's under, so if you go to your on-campus messages, you're gonna see, let me show you what you're gonna see. You're gonna see just a message from me on campus that says link. You'll click on that. Let me walk around though and see if you can help. Once you guys are logged into this class, though, you can go ahead and start working on the worksheet or finish the worksheet from last night. That would be homework.